whatever it is.
Yeah, well, and I'm also curious to get your take on like scope of the project, what you want to see sort of longer term, and because I think this has a ton of potential. So
it needs to be picked up.
Yeah, but like we can sort of chat about how
here's a frame.
Make that happen.
First step at it.
Yeah.
I believe that Diane and Craig are writing a proposal with GeoSci.xyz.
Yeah.
And this would be sort of like a first pitch, just to show what kind of flavor of things they're doing after.
Yeah.
And hopefully, if they get money, then someone else that knows Python can just pick it up and
that'd be great.
Yeah. Because I don't think any of us will really have time to do it unless you want a project, you want a pet project.
I got a lot of other projects there.
Yeah. That would be more like in the new year, I think.
Was here. It sounds good.
Think about it. Okay. So I share my screen if you want to click on this. So this is the current live version, and it's not doing exactly what we want. So I will show you the local version instead, but it's under a toolkit at GeoSci.xyz. So it's under the bigger umbrella of GeoSci. And the idea is to give simple tools so that geologists can start tackling, use geophysical data without having to learn like a whole package like GeoSept or ARC or big software that have the capabilities to do most of this. But you need to learn the software. And, you need to learn all those parts.
Yeah.
Before you can start just asking simple questions with data. So we're trying to kind of like bridge that gap, get an easy entry point for geologists to get and do those tasks.
Yeah. One quick thought as I was looking through stuff, I was wondering about the title actually. And like, so my only thought process there was that, and this is a scope question really, is like, do we envision outside contributors at some point?
Mm-hmm.
And if so, then we probably shouldn't have like MDRU and GIF in the title.
Okay.
Just because then it sort of like
Limits.
assumes that like if I'm not in MDRU or in GIF, then I should
do this. That's good.
That was just one comment. But I think like the branding at the bottom saying like supported by MDRU and GIF is perfect.
Okay.
And if you want, we could even put that in the footer so that it's on every single page.
Yeah, no, that makes total sense.
Yeah, but that was just a first thought. So just even calling it like geophysical toolkit for geologists.
Yeah, absolutely. That's great. There's a lot. I think there's more left to get into the site. Like all the titles need to be shortened, and don't worry about the site. Like this is just a thing. The neat thing that I like that currently we're not supporting on the live version is the NB Sphinx compiling. So go directly from a notebook to an RST, and right now it's doing its trick in terms of the text is there, the headers are there from the notebook, but the figures are not showing. And this is, I think it has to do with the NB strip out, because I get the same problem on my local machine.
Oh, okay.
You need to strip we need to do a strip right before it builds all the HTML files.
Oh, okay.
And I think it's because it's doing all the tests before, it's hitting all the notebooks.
Yeah.
And then when it's building the site, that's what NB Sphinx does. It does not run the cell if it has been run before, whatever, it's a detail. But so we need to put a strip like right when it builds the site.
Okay.
Which I'm not entirely sure when it happens in the whole like Travis cycle.
There's two options. I think we can do it in the docs themselves. Is like, so in the conf.py before like sort of the first step in the build is just strip out all the notebooks and then build the site.
Okay.
I think we can do that.
Let's look at it.
At the very least, yeah, we can certainly like even after each test, just run it.
I tried to do that, and it's still
and it still crashed. Okay.
So yeah, we'll have to figure it out.
Okay.
It's okay. It's minor details, logistics. So I will show you the local version instead of the live version, so that we can see the images. Okay. And then these are technically already on Binder, so we can Binder. So they are right now 7 notebooks. and they're separated into two kind of modules. One is using a synthetic example, and the other one is using the search dataset, which is a free dataset from the VC. So maybe what I want to do today with you guys is look more into like what kind of functions that we had to implement, and maybe if you see interest to bring it in SimPEG, some of the components, then we can do this, or see how we can do it. The first one is how to grid data. So if you start with lines, just line data, different methods to interpolate, and how does that look on your grids, right? So if you just do a nearest, it looks like this. If you do it near, it looks like this. The first three are using SciPy. Minimum curvature. I implemented the minimum curvature, and it ran off a bit slow, but it's really good. Minimum curvature is way better than the other interpolators, and mostly to deal with like long distances. You see the difference between cubic and you didn't see it, but this is cubic. You see there's a lot of inline kind of artifacts, and when we're going to do the FFTs, the Fourier transforms, this kind of stuff like really shows on the.
Is this something like that implemented in Variando, or is that?
Minimum curvature, I don't think so. I think Variando assumes that it's already gridded.
Okay.
Yeah.
Yeah, I mean, that would be a great thing to have in SimPEG, I think, as a util.
A util.
At the very least. Yeah. Maybe actually, it might belong in discretize, in fact.
Because you send it to from a scatter to a grid.
Yeah.
Think about it. So there are a few ways to do minimum curvature. There's like a spline method, and there's like a relaxation method. I think we worked on this together a while back. Sorry, this is SimPEG. Are you? No, you one there. Sorry, I should have been ready for this. Toolkit library. Minimum curvature. Yeah, so we have two ways: splines, which solves small inverse problems, and the other one is a relaxation, which is just a bunch of averaging applied multiple times until your system kind of relaxes to a steady state. This one is it's really nice when the points are really scattered, because it takes a lot less time to interpolate. Yeah. The relaxation takes a long time and the points are really far apart, but you need to generate a dense system, and that eventually gets too big for large
that
problems.
was the spline one, did you say?
Yeah, that's the spline. Yeah.
So it's a 2D spline.
It's a 2D spline. Yeah. So you're solving for coefficients.
Yeah.
That has like a distance and a log term in this, and then once you have your coefficients, you're just applying those to your grid. And right now it's pretty slow because I'm doing everything in for loops, but I'm sure there are smart ways to do this. Okay, so anyway, this is one thing that we should think about bringing in, is the gridding.
Just on this map, it's very, it's nothing, but can you show again the color map choice that you have?
Yeah, so I tried to cover both divergent and like even this one that are the GeoSci one. I think GeoSci one is this one. Yeah, and it's a whole conversation that Diane put in the notebook, is choice of color maps, and debates that is happening currently in the industry, like what color maps are best and why not.
There's also, it might be worth linking to the Matplotlib docs there. There's a really good tutorial, and they actually show you in space what the spectrum of each color map is.
Love it. Yeah. Let me just bring I'm just gonna add those comments and issues right away. So
Yes, it was like when the release came out, they even like I think it was a sci-fi talk too.
Yeah.
And actually, like I was like, oh, I'm just gonna check out what can they talk for like half an hour on the color map, and actually I ended up watching the video, even just enough science and like how a color map can bias your interpretation, etc. That would be a cool link to put also, just like for people that really want to.
There's one talk in the geoscience space by Kristen Thing. She's at Texas A&M, I think, in oceanography. And she gave a really good talk on just like when to think about using different color bars, like when should you be using diverging versus linear. And like also she had a really good discussion in there on like when to use nonlinear color bars and like when it's okay to highlight different things. I can try and dig up that link too.
I'm just gonna write this down. Cheers. Okay, perfect. Let's do previous comment that you've done. Okay. Are we good for this?
I was going to add for the color bar, I think the choice if you thought about like for each color bar that you have to also give the option of the reverse one. We were just talking about that with this the other time, but just like it was about resistivity and conductivity, so it's a bit different, but like he was saying that he was seeing a difference between his contract between the west and the east, because one was looking for resistive target in a conductive environment, and the other one was looking for conductive target in a resistive environment.
Okay.
But both sides wanted to have the red as anomaly, so like they were switching color bars depending on if they were giving the report in the east or the west of Canada.
Okay, yeah, we'll add it as a button instead, because otherwise the list's gonna get too long.
Yeah.
Right? I could probably put a button here for reverse. I'll tell Diane and see what she thinks. Reverse color. Reverse color. Okay. Sounds good. I like that. So this notebook is really just a preparation phase for the rest. We don't have this part for the search data set because we're already assuming that it's a gridded data set. Okay, so it's kind of like a notebook 0. For the synthetic viewer, this is new to be able to, because right now in SimPEG we can add a block or a sphere or objects if they're an upright rectangle.
Yeah.
Upper lower corners, and you just assign values in the middle. But we didn't have the option to identify values inside the block in any possible orientation. So this has been added in the it's in this guy. Wow, that's bad. Problem setter. Second, guys. Okay, I will have to, looks like we already had it. Looks like I'm using SimPEG for this. Huh. Okay, never mind. I'm not too sure.
This was for adding the block and rotating it?
Yeah, that's right, to add the rotated.
And then it just discretizes onto whatever underlying mesh you've got.
Yeah, but it looks like we already have it. I'll have to repeat this. That's cool. Looks like
You probably added it because we certainly didn't have it initially.
We had something like that for the DC app that Tibo and I did a
Oh,
while
okay.
ago. Like we
Oh, maybe
definitely
I got
messed
it.
around with
What's
stuff like that in that
Oh,
plate
yeah.
app, that DC plate app.
Yeah.
So I remember doing some stuff with like rotation matrices and all that kind of stuff in there. And I think we could just specify any. I don't remember. I think we probably specified the block.
Yeah, I don't remember that. We at least worked for like a power block. Yeah. And we probably put that in the DC pull request last year.
I don't remember for sure.
We're in utils model builder. Poly. That would be a good one to put an example up if we already have it, because
Yeah.
I was looking for it. Yeah, okay. In a poly 3, never mind. We have it.
Cool.
It's using it's using the Delon.
It's beautifully documented.
That's great. Okay, whatever. So there we go. We're using SimPEG for this one. Okay. I was here. So okay. So basically, Diane was interested in this scenario where just a regular positive mag anomaly, a big domain, and some demagnetization inside the domain. So we made it with three different blocks basically. One like this, one big that is like way bigger than our domain, and one that is cross-cutting like this. And we learned on Friday that geologists are interested in demagnetization, because if you have truss faults, you have fluids, and that breaks down magnetite.
Okay.
So any faults will usually show as a magnetic load if you're in a highly magnetic body.
Brilliant. Wow, what a difference a weekend can make.
Because usually we're used to intrusions, right? Like magnetic intrusions. But here they're talking about destruction of magnetite. Yeah.
Cool.
And then we've, okay, so this is like a SimPEG one, and talking to Doug, we can profile, we're just allowing the user, the same thing will happen with the real data set, but it's just to introduce the
nice.
things, right? So people can slice the data set.
Nice.
And change the resolution to show what happens if you undersample your survey, that kind of stuff. Okay. And then we're providing this little guy here, which allows you to see your data set at different places on Earth. So we're just moving the marker around.
Oh, that's cool.
Just to show when the inclination declination changes.
Not nice.
How does
That's really
your
nice.
survey changes?
And I like that you picked like specific cities rather than. I think that's cool.
And then that's TMI, right? So the North Pole and the South Pole normally looks very similar, even though the field orientation is
Oh, that's really nice.
almost the same. The most dramatic is when you're near the equator, like if you're in Peru. Peru, I think it's pretty flat. Yeah, Peru, it looks very different. How to interpret this is much trickier, I guess. That's the take-home message. Okay, and after this, we go into the filters. I'm going to go straight to the search because it's much more interesting. We've done that. So this is the data set from the BC, Geoscience BC. What the app will let you do is carve out a smaller area so you can move that window around. And right now it will break if you have holes in it, so I need to work on this, but so you can move it around. And after that, you can run the filters. Okay, now so this one, the viewing again. So the viewing, you can just profile it again, same thing. Just profile the data set. Okay. This one, now we're adding a little bit more functionality, so we can do sun shading. So decide what orientation of the sun you want it. This is quite nice for to highlight different structures in your data set. Shows the difference between a linear color scheme versus a histogrammic equalized, and this we should add to the SimPEG stack too. I took it from someone else, but we should link to it. Because to look at data in linear versus equalized makes a huge difference if you have big anomalies.
Yeah. That's nice.
And again, you can do all the different color schemes. You can play around with transparency if you don't want hillside, or if you want only hillside, then you can do this. The neat thing is that we also put this button here. It's export as GeoTIFF. So what it does is that it exports a GeoTIFF file with the EPGS code attached to it. And then, look at this, guys, how cool that is. It throws it in a output folder. Okay. And now you can load it in any, I think I showed it to some of you, but any other software that can digest the GeoTIFF will be able to read it, including Google Earth. So, sorry, Google Earth will take some time.
That's slick.
Yeah, so we're just going to be able to load it in straight Google Earth. Just thinking about that. So all I need to do is import. We'll pick, let's see, GeoTIFF here. Let's pick them all. And there we go. We're in DC. Resolution is too high, so we'll just downsample a little bit. And then you have control and opacity, so you can like highlight different things. And it's exactly what you've created here, right? So all the color scheme, hill shade, and everything is just grabbed exactly that picture and then just puts it in 3D. So that means you can layer, right? You can choose to like do different things and then layer them all in Google Earth, and then after that, just go here and change the transparency so you can overlay different images. So that gives a way for users to take their work here and then carry on their analysis somewhere else. They don't need to stay here. So this is the viewer, and after that we switch to the filters. Filters, I originally was hoping that I could do it with Fatiando, but the way the papers were done, there was a lot of artifacts coming in. So I just I kept the structure and just rewrote the way the paddings and everything were done, and now it looks a little bit better. So the goal is to eventually push that change back to Fatiando.
Have you been in touch with Leo on that?
Not since our last meeting, yeah. Yeah, that was a while back. So the idea here is we start with the upward continuation, because once we have at the right level, we can change the frequency content, right, by just upward continuing our data. Then after that, all the filters will adapt to it. So I'll show you. For example, this is horizontal derivative of that data map. And now, if I upward continue it a little bit, you'll see the content will change, right? So now we're losing the high frequency quicker. Yeah, and now I can just update, refresh my view. Now I get the FFT and the different. So people can start playing those games of attenuating, looking at deeper elements by moving the data out. And then same thing here, you can highlight different things in your data set by just changing the sun. And then changing angle, it can go crazy. So those are the X, the Y derivative, vertical, total. Tilt is important because we're going to use this one to as a way to figure out the depth of the anomalies. I'll show you the other notebook after. Next signal, then reduce to ball. So we have all the major filters. And again, you can export these guys so that you go in Google Earth. I guess we are at a different place, but they should line up anyway. Again, you should go between your data and your filters. Like so. Now, the last one, and that's probably going to be the end of it for us, because we only have 1 month left to work on this, and we just need time to polish everything and make sure that everything's running. It's to detect, try to estimate the depth of the anomalies. So same thing again, you can select a different area, do the upward continuation, and then we wrote a shapefile exporter. We're leveraging from someone else's code, but now we can export lines into a shapefile. And yeah, this guy is just estimation of depth of all the anomalies. And the same thing is that, let's see, we change the color. I'm gonna put the data in gray so we can see the contours. If we upward continue, and then we refresh. Now we're estimating like just larger bodies, right? So it's just telling us that in this region, the anomalies are deeper than in the central region where it's shallower volcanics. So Diane has been, took this, and on the site, she's just showing people how to, you can bring those shapefiles into a different software. For instance, Arc, right? She just brought those contours and shapefile to Arc, and then she can do all her rest of processing, like putting mine sites and fancier colors on the contours and all that. So that's it.
Were there actually Earth references for that, as far as what the depths were for the bodies at any of those places? Like, do you have some kind of ground truth?
Yeah, good question. We obviously did it on our synthetic example, and we got the depth was really good. Yeah. So if we run it on a synthetic example, it puts the anomalies at 100 meters, and that's where all they are. This one is 100 meters, this one's 100 meters, this one's 100 meters. So it's pretty good. Yeah.
That's really nice.
So the site, yeah, eventually we'll have links for the binders, I guess. And because all these are directly translating from the notebook to the RST, you don't need to worry about making sure the notebook runs. If the website builds, then we know the notebooks are good. And then Diane can save time to not have to rewrite this into an RST. So that was pretty neat for next time, right? You can write content directly in the notebook. Yeah, pretty good. Yeah, that's it from me. So there are a few things that we should probably think bringing it in. For me, filters back to Fatiando, follow up with them. So we don't have to have two separate libraries. We can just do it all there. And I need to figure a way to be able to do the FFT if we have holes in our grid. I think it's going to be like an interpolation, probably a minimum curvature inside the patch that is empty. Do the FFT, and then carve it back out, and then see how much. Hopefully, there's not too much artifacts around the rim of it. Worst case, chop out maybe a bigger region on our grid just to be safe or something. Yeah.
It's really slow.
And then, yeah, I'll need your help to fix the deploy on the site. What was needed for it to work locally, and on Redux it worked as well, was to add in the conf.py, as you were saying, is to add the stripping function.
Yeah.
And so I tried to add the same stripping functions to the test, but it's not doing it. So if we look at the test,
But if it's in the conf.
like I added the strips like before and after the test, and still that's not enough. So somehow when Travis builds it, at one point it wants to create the HTMLs and they are already compiled, so it just skips over.
Okay.
Yeah, we need to find a place to put this.
Yeah, fair enough.
Yeah.
We can
So where is this all going to fit within the hierarchy of GeoSci and SimPEG?
So currently, yeah, it lives under the GeoSci.xyz banner, but we don't have any exposure. It's hidden. This toolkit one, you need to know that it's there. If you go to GeoSci.xyz, I don't think it's.
Yeah, we haven't added a button yet, but we can
We
certainly
can do that.
Yeah, that's an easy thing to do. All I need is a square image. And then that.
For landing.
Yeah,
Okay.
for the landing page. We can set up.
Yeah, so it could live. I mean, it would make sense for it to live there.
Yeah. Yeah, and then I think like as much code as we can sort of, that is useful to bring into SimPEG, we should give some thought to that. And maybe the first thing to do is even just like create an issue on SimPEG, just pointing to the code, and we can figure out then where it lives.
Oh, yeah.
Because then we at least like just document that this stuff needs to be moved over, and we can start looking into that.
Yeah. Ideally, it would be just, I would just have a simulator, the simulator function that handles all the widgets and everything.
Yeah.
And maybe one or two that, do stuff, but like MathUtils, this is all stuff that should be leveraged from SimPEG.
Yeah.
And then all the gridding, all the FFT stuff should all be elsewhere. Yeah.
That's exciting. That's really neat. The other thing to think about is like to get a bit more exposure, we should think about writing like a leading edge type article. But maybe more so, I don't know what the geology equivalent of that is. Like leading edge is, that would be a good place for the geophysics side, but actually we're trying to get this to geologists.
Yeah, it would be economic geologists, one of those papers.
Yeah, something like that. So like once like it's sort of ready for prime time, we should think about that. 'Cause I think we were just saying,
what do you think?
we should write like a leading edge style article, not leading edge, somewhere that's geology oriented, but about all of this, because this is, I think that would be a good way to spread the word and get people involved. Yeah.
At this, I think like further down the road, if someone else had picked up someone else picks up this project, there's like, can branch off, right? We can do like gravity, all the processing for gravity there. And you were more advanced ones, the whole like, we were talking initially to do the edge detection, parametric conversion. There's like way more we wanted to achieve.
Right, yes,
but we won't have time to do it. So I think when we think of reshaping the site of the INDL, we should make sure that it's obvious that there are like tentacles that can come out of it. Because right now, right up front, when you look at the site, all you see is magnetic filters, basically.
Yeah.
Which is okay for now, because that's all we have. But maybe rethink a little bit what's going to be the top header of that site, and how these guys look. And even like I started looking into it, to just do even unconstrained inversions. It's pretty easy, right? Like we have, the data is already prepped. We have a mesh generator. We can just throw in the defaults and then make them compare at least the estimated depth from what the inversion would look like, and just give them first entry point to an inversion so the geologists can be interested. I know it's not a popular idea. Joe always telling me this is a terrible idea. You don't want to let geologists invert, but I think down the road.
I don't think that's true. I mean, look at some of the best inversions that came out. I mean, well, first of all, Nick was a geologist, but he kind of converted. But also, Ken Hickey did some really interesting stuff. And he has no real concept of what's going on, but he was definitely able to press buttons and see stuff that at least he thought was geologically informative. So, from the point of view of having him do anything other than the default, I'd be a little bit skeptical. But there's training there, and there's ways of building up background. So,
because I think like we were talking about edge detections and estimating the depth and everything. And I think it would be easy to spend a lot of time doing like old stuff or stuff that is like super tedious, where just an inversion could give us the first, could give us a good first estimation of this. Sorry, I'm just gonna show, when I started looking into doing the inversion, the default inversion, I was looking into this. There's like French guys that did this, right? So we could allow them to export specific sections, and just same thing as we did the drape, you can just show the cross section of the inversion as an overlay on Google Earth, which would be a good way. Don't have to worry about like 3D viewer or mesh tools or whatnot. You just export section, say I want to see that section, export it, and then you just drape it on top, right? Just a quick way to expose the inversion results.
That's nice.
And these guys provided the how to write the KML file to be able to do this. So it didn't be too much work. Nice.
Can I ask what a KML file is?
It's what the Google Earth digests.
Oh, okay.
It's just a file format. Yes.
This is really nice, Tom. This is really nice.
Yeah, I think hopefully. So Diane wants to give a short course, and I think she wanted you to be part of that short course in October. It will be a day-long type of MDRU, just showing people what we worked on. Hopefully get feedback. Yeah.
Well, and opens up the door. Now you got something tangible, right? That will really capture their imagination. So that will, from the point of view of Geoscience BC or other groups, and they're like,
that's what you're talking about.
Yeah, so that's what you're talking about. I get it.
Yeah, it's first pitch,
Yeah, but it's an impressive first pitch.
Yeah. As long as they see it's possible.
Does she want people running the notebooks and all of that?
Yeah, so I'm so scared that if we require users to install it, we'll lose a lot of people. So I think we can do as much as possible in Binder or Azure.
It's a one-day thing? Because one of the things we can do, so the notebooks are not heavy on Binder, but we could also, actually setting up a temporary Jupyter Hub is not a hard thing to do.
Okay.
So if she needs to do that, we need a bit of lead time.
You just pay for that day.
Yeah. It probably is still under the free. Yeah.
But can we use the Scusi? What's their
Syzygy?
Syzygy?
Probably not, because it's not. It would require authentication, and so Ian. If they're all UBC people,
which they would.
I think she wanted to. Yeah, most of them, but I think she wanted to expand the invite to.
Yeah, so she wants to expand the invite. Probably not. You could run it by Ian. He might be able to give temporary access to people, and then if that's the case, that's great. And that might be totally doable. So, just an option. But
if we can get better at using Jupyter Lab on Jupyter.
Yeah.
I guess it's free. That's why you were saying CDG would be better.
Well, and then we don't have to like manage the installation. and
Yes,
all of
yes,
that.
yes. That's
It's just
true.
taken care of. So,
Okay.
Yeah.
Yeah, we will test it on Binder first to make sure that's stable.
Yeah.
So that we can worry about heavier deploys, I guess.
yeah. And I'll give you some pointers for creating the binder links. And then also, I think it's worth creating like an index notebook so that you do have sort of a showcase for when people first hit the binder. Instead of seeing just the listing of notebooks, they actually come to like a notebook that's got some description and pictures and stuff like that.
Okay, I lost track of what you're saying, but yes.
Oh yeah, I'll show you. So like with the apps, for example, if you go to any of the binder links, we've pointed the binder link to an index.
Oh,
notebook.
yes.
And so it's just like a little more friendly than here's some files that you don't know what they are.
Yes, absolutely.
So yeah, that's all.
And then I would like to add the gallery like we did in SimPEG, like you did in SimPEG.
Yeah.
Here, right? So right now, like she kind of did this. Like gallery could be here. Yeah, gallery
It might
could be
be
here.
easier, so we can look into that. I don't know how well NB Sphinx and the Sphinx gallery play together.
Okay.
There's two things that we could, if they don't, then we can do something like the case histories page in GeoSci, which auto builds. So all we would need is then like a pointer to an image of the title, and that's pretty easy.
We just need to prep a figure that lives always on the totally.
So
That's easy.
yeah, so we can figure that out.
Yeah, that's good.
If you want to start an issue and like ping me on that, I can keep that on the list. Cool.
Yeah, that's great.
Thanks, Sean. That's really exciting.
So Diane's last, when is she finishing up here? Because it's about a month, right?
Yeah, yeah. First or 2nd of October, she's taking.
Yeah. So that means that she'd probably want to have something fairly shortly after, right? When's she due?
I think she's going to be due like at the end of October or something. Like she's not giving herself much rest on.
Okay.
So it would be, I think she probably is aiming for end of September to do the short course, and that will give us 2 weeks to just really wrap it up. Whatever extending issues there still.
Something else for the end of September.
Yeah.
I think nothing else.
I don't think it should last too much from you.
Yeah,
It's
no,
mostly
but
gonna
just-
be like,
Just
what
as,
is
but it's
magnetic?
still another group thing that
Yeah,
make sure we got
totally.
right. Acquisitioning, so like where we want to go.
Mhm. Any comments, you guys, from my first side?
It was good. One of the things I think I like too is you put in the effort to give explanation of things in the markdown in the actual notebooks. Instead of like, here's this app go, they can read through and actually understand why they're doing these steps. And it's going to be very important for them to have that.
And there's a beauty with the Sphinx is that everything that's on the site, if someone grabbed a notebook, they pretty much grab in the site.
Yeah.
All right. So as much as you put in your notebook, the user is going to have all the information that they need. Don't need to go back.
That's something we should do, like even with the EM apps and with GPG and all of that sort of stuff.
Definitely.
Yeah.
Yeah, because now exactly all your documentation lives with the code, right? So
Yeah.
you don't have to be scared that
Stuff's getting out of sync or.
or people pulling the notebook and then they don't know what they're looking for.
Yeah.
Everything's on one space.
Yeah.
Thank you, Andy Sphinx.
I have a question or suggestion for your synthetic example.
Okay.
Can put that up again.
Just the top part, like this one, or
Yes, like that. So
oh, I'll share. Sorry, turn it off.
So we have this model, and then you generate the data from that.
Well, the data is generated from only the three presents, not the discretized version.
Yeah.
Yeah.
But and it was more a visualization thing. Like,
Oh,
kind of like when you visualize your Mac data,
Yeah.
what do you think if you had like the contour of the blocks
Yeah.
on the plot? So we can have like we have like kind of like a geology information layer
Totally.
on top of the.
It's part of the issues. Yeah.
Okay.
Diana already requested that from me. Yeah, so that you're exactly right, man. And everything, sorry, I'm here. All the filters for the synthetic and everything, I'll always put the outlines of the blocks so we know where the edges are.
Yeah, so that would be a great thing to put. So like, follows the thing where you choose where you are. That would be great to like just have like it's the same model and you have always the same control of the data change a lot.
Absolutely. And the filters, yeah, for the filters too would be really nice, right? Because do I have the filters? Synthetic filters. Because when you look at the, and I'm also going to add profiles in the comments. When you look at the filters, like if you have the block, it would be nice to see it, right? Because, like for instance, the little gradient. I'm like, okay, what does that mean? The high, is the high at the place where the edges are, or it's hard to make that correspondence if you don't know teaching. So yeah, definitely. Good point. Anything else, Mike? Your thoughts?
We have code to do that too.
To do what?
To put in those edges if you want
it. Using the underlying model. Yeah.
Yeah. Just looks at the derivative of the model and place that derivative is changing.
Oh,
then
okay.
cell by cell and draws the outline of the.
I was using contours. I was just contouring in like a flat slice with a contour flat slice. You just shoot the contour. That's also it's also really fast. Good.
Yeah.
Cool. Thanks, Tom. Any other questions, things people want to go over? Stuff to discuss?
I wasn't here a couple of weeks ago, but then there was this talk about discretizing integrals for inversions.
Oh, this?
Yeah.
Yeah.
Has there been anything done on that, or is that still on the to-do list? And also within the context of SimPEG, what actually is there for documentation or tutorials or stuff with respect to calculating gradients or kind of working on a mesh and then transferring whatever objective function you want to that into something?
I mean, we've got like the documentation of the API, but that's actually basically it at this point. There's a few examples that show different regularizations, but there's not much actual discussion on, there's not actually a place for it. So this is one of the things I think we really need to think about.
Does this all go on to discretize?
Some of it will, not all of it. I think that like the discussion on regularization should go in SimPEG.
Yep.
So I think one of the first things that we need to think about doing, I'm just going to share my screen so this is captured, is doing a better job organizing the docs. So right now there's it's interspersed, like information about each thing is interspersed with the API. And I don't think that that's how we should be doing things. I think that we should separate it out. Like I really like, for example, the matplotlib documentation. Each page is like one specific thing. It's pretty straightforward. I realize that in a lot of ways, SimPEG is more complicated than that, in that like we can't just document like a plotting function. Like if you want to be using regularization, you're thinking about an inversion, and it's part of a bigger picture.
Can you give an example what you're mentioning, what we're doing and what you're...
So right now, for example, if we look at electromagnetics, there is a bit of theory, and then the API is at the bottom of this page. So it's a really ginormous page where we sort of have theory interspersed with the code. And so here we've got theory, but then we also have like how to use the function. And I think that that's not how we want to be doing things. I think we want to try and separate out theory and say, if you want to use, like solve an EM problem, here's documentation on like actually setting up a problem. So I think we need to tease those things apart a little more.
And a page only on the class for the class base.
Yeah.
So I might have actually done that already with the stuff that I wrote. Because I found it pretty confusing to look through.
Yeah. So we need to tease that apart. And so I think the biggest thing is
so
yeah.
Yes, we have a background theory and then the API is completely separate.
Yeah, so I agree, like that's a good way to go. And we should actually really have like usage. So not just like hopefully for a lot of the theory, we can actually push this over to EM GeoSci or to the GPG or wherever it's relevant, so that people are like, here's a textbook if you really need that level of detail. Because we don't want to be doing that in the SimPEG docs, but we should have usage that sort of just talks you through, like, here's some things to think about in a mag inversion. Here's the functions you're going to need, and here's maybe a small example. And then have the API separate. So if people want to go in and look at actually all of the functionality available, they can.
I guess one of the reasons why I put this stuff here is to make sure that the user knew what assumptions and what other things were done for that formulation.
Yeah, no, and so that's great. And like, I think sort of maybe looking at this, there's some material that we can potentially parse out.
Yeah, it's a little dense.
But that's fine, and there's no problem being overly dense, because like this content is going to remain useful, and it's just a question of where it lives. And so for right now, this is perfect. And so like, Doug, to your question about regularization, like, first of all, we don't even have a top level title that says regularization, which I think is a problem. It's under inversion components. And then we do have regularization. We have some theory discussing Tikhonov regularization and how that's discretized. But that's the only theory that we have for the regularization. The rest is then documentation of the API, in which there's some information interspersed, but again, it's kind of all tangled.
I to answer your question, like I started a notebook and I pinged you guys, but I can't find it. I'll find it and send it back to you, so because I started something about it, so we can iterate.
I think what might be helpful to think about is just like a series of really small focused notebooks on, like, okay, I've got a specific problem, so I'm going to just use, let's say, a smallest model, and also I've got a variable mesh, or it could have a variable mesh, and then carrying that through, and then actually showing what the final discretized form of that is, and maybe even hooking it up then to a linear inverse problem would be really interesting. And then you could just progressively substitute things out, and that'll get, if we had that ability, that'll kind of come and allow us to kind of work with problems like that when you've got like a really crazy mesh for some reason or other, and you're really changing what the scale size is of your meshes. Because I think some of the problems that you are encountering perhaps come back to just the definition of what the gradient is and where it's living, right? So when you've got adjacent cells that are really different in size, right? And then you've got, your estimate of a gradient, but you've got different sizes, so there's some ambiguity there as to what it is you're really calculating and how you want to think about it. And so that's where, in your case, you were effectively getting rid of that change in scale by having, I got a small cell here and a big cell here. And if I just go ahead and use the regular gradient, which goes from the middle of this one to the middle of this one, and then put that in, then I get out something, okay? It turns out that's, perhaps in your case, that's not what you want, but the understanding of what's going on is that there's some ambiguity in what you actually have for the gradient. And just being able to explore things like that at a very simple level, I think would form a foundation that would be really just a thought.
Yeah. Yeah, there are many tutorials that we should have.
Yeah. But some of these at a fundamental level, which involves discretization of whatever operators you've got, and then solving either recomputing the integral of that thing or using it in an inversion. I mean, those are really kind of base level problems then that filter up into everything else. So I think those are kind of nice to have in mind.
Yeah, so I think like for tutorials and notebooks and things like that, they're sort of separate right now from the SimPEG docs, and we should rethink that. Because we do have SimPEG/tutorials, I believe. Oh, yeah, GeoSci.xyz/computation. So there's a question of like what this is actually, because I think right now we've got the leading edge tutorial in there that was on like discretizing the DC equation, so finite volume is in there. We have a whole bunch of stuff like sketched out, and so I think, yeah, let's give some thought to like how this interfaces to the SimPEG docs. Are they actually the same thing? I think they might be, and how to go about and merge that and do that in the same way.
Mm-hmm.
Yeah. Okay, well, it's 11 now, so I think we should wrap things up. If there's anybody who has ideas for next week, just ping in the Slack channel.
Sounds good. Thanks.
And thanks again, Dom. That's really exciting to see.
Yeah, I think that's really nice. That's great.
Good.
People are going to be excited about that. And what that does is just put such a tangibility on, things that we can easily talk about, but that nobody has really got a sense of how it would impact. I mean, now it can, the fact that you've hooked it up with synthetic and with the search data, and do various things, overlay that on Google Earth, and that's great. I mean, it's, well, not only get a conversation going, but actually, people could start to use it.
Yeah, that's kind of something that kept coming back. It's like, oh, well, GeoSup's already doing this, or this guy's already doing this. I'm like, yeah, this is not new stuff. It's just you need to give it easy for people to grab it and interact with it. That's the only goal here.
Well, and having the content to actually walk through what's going on, rather than
training it around. Yes, that was Craig's first thing, right? He wanted to stop repeating himself, always do the same. Show one person one at a time what their filter's doing, how they're computed, and all that.
Yeah.
Hopefully, this kind of like helps him out. Yeah. One more month.